They're awesome.
Here's the corollary. So the objective of this talk is to get a good general understanding of Elasticsearch and what it is as a search engine, and also using it as a NoSQL data store as well. So a little bit about me. My name is Craig Brown. I'm been a search architect and been working on Hadoop big data, and I'm currently doing some consulting at the moment, and I have a blog there and a Twitter account there if you guys are interested at all. So Elasticsearch. So who's familiar with Elasticsearch at all? Okay, about half roughly. So Elasticsearch is a search engine that's based on what we see in core, very similar to Solr. So who's familiar with Solr in the room here? Okay, a lot of people. So that's not surprising. Solr has a much bigger, it's been around quite a bit longer, and has a much bigger following than Elasticsearch has. So it was essentially written by this guy named Shai Bannon. He wrote about, almost 100% of the first few releases. He's since formed a company now and has some people hired on. There's a lot more community involvement than there used to be. ElasticSearch.org is the site where you can find out about. ElasticSearch.com is kind of the corporate site now. The latest release, .90.3, is built on a Lucene 4.3 core, if you guys are familiar with Lucene at all, kind of the underlying engine for it. And it's really built around JSON over HTTP. That's sort of the core, one of the core features of it. So as I'm going through this stuff, I think we've got some varying levels of knowledge or experience. You guys are welcome to ask questions. I can be pretty flexible with the presentation if you guys want to spend a lot of time answering questions or go off into asking questions. I'll answer questions. Feel free to pop up and see what we can do. So Elasticsearch, I don't know if you guys know a lot about Solr. Solr essentially was built as sort of a single node, kind of a search engine, and they added Zookeeper kind of as a way to scale the product, which is a great way to do it. Elasticsearch was built kind of out of the box as a scalable search solution. So some of the underlying architecture there is a little bit different. Has support for multicast, unicast, and special AWS scaling mode that makes it really easy to set up and scale clusters. A lot of people are using AWS these days, so that could be kind of a real advantage. It's open source with an Apache 2 license. Uses HTTP as a main transport. We can also use memcached and thrift. And then it also supports an internal scripting abilities to be able to do different things like documents updates, and it's used a lot for custom scoring. So if you want to kind of implement your own scoring algorithm, then this is one of the ways that you can kind of accomplish that. So a little bit about what it looks like. So from a kernel or an HTTP perspective, it's really easy to jump in. Elasticsearch is Java-based, like Solr and some of the others, but it's kind of object-oriented on JSON, so the interface is a bit different if you're familiar with Solr. So these are an example of 3 different documents that we can index. We don't have to define any kind of a schema. We can just, we could just shove this into Elasticsearch and say, look, this is my document. I want you to do something intelligent for me, right? And most of the time, it's pretty good at it. So once we have data in the system, we want to be able to try to search it, right? Sorry, go ahead.
Sorry, you're saying this is schema-free, so in contrast to Solr, you don't have to define any of the fields you want.
Yeah, Solr, from what I understand, is more field-based. You get just sort of a list of fields that you end up putting in. And if you have some kind of an object structure, you have to, basically flatten it out manually. Elasticsearch does something similar with the fields because they're both using Lucene under the covers, right? But it does it for you, which makes it a lot nicer. So you can put structured or more structured documents into Elasticsearch, and it will, sorry, go ahead.
So with it doing it for you, you can also define how like the field is indexed and stuff like that. So you can say I want to use n-grams instead of, token, instead of just general space, but white space.
Yes, exactly. I don't have any examples of building a schema in this presentation,
Okay.
but this kind of more of the intro thing. But yeah, absolutely. So where Solar uses XML to define all that stuff, Elasticsearch does it all in the JSON document, and you can have a settings and a mapping document for any of your indexes. It's kind of interesting in that you can actually define rules for mapping. So, for example, one of the gentlemen was over here was talking about doing log searching, log analysis with Elasticsearch, which is very popular. So one of the things that you could do is you could define, or one of the ways that it's commonly set up is that you gather your documents by day. So for each day, it's a new index. But you can give Elasticsearch rules that will say, look, if the index sort of has this name, I want you to apply this kind of a schema, and it will do it for you automatically. You don't have to manually, or programmatically set up, okay, here's my new index, it's created, okay, now I'm going to put my data in. It could do a lot of that stuff for you, which is really nice.
And then one last thing on this one, I see put. And generally, put means you can do that as many times as you want, right? And it's idempotent. Is that what that follows? So does it?
Yes, yes.
So it won't create a new name. It won't create a new document for Shive if you do that 10 times, or will it create a new one?
Yeah. So let me describe this just a little bit more. So localhost 9200. So Twitter is the name of an index, and tweet is the name of a type. So each index can have its own type, and they can be searched differently or independently based upon how you form your queries. In this first example, you'll notice that the type is actually user. So we're going to put two different types in the same index, and it will kind of manage that for you. I'll show you a short demo to show you how some of this stuff works. So kimchi actually is the ID of the document.
Okay.
In the second one, the ID is number 2, and then the third one here, the ID is number 3.
Okay.
You don't have to supply an ID, and Elasticsearch will supply its own. And actually, it has kind of its own other ID that it uses internally to help manage documents. So
and that's more of the doc, right? Doc itself, the doc ID.
Yeah, exactly. And so this is all, if you guys are familiar with a lot of the NoSQL terminology, this is, you can think of this a bit as a document-based database, right? With full text search engine capabilities, right? Which is really nice.
So is there a standard NoSQL database running underneath this, or is it's just built in from SQL?
Yeah.
Well, Lucene's the search engine that indexes everything, but is there a NoSQL database that's hooked into it? Another open source, or it's just its own?
Sure. So the question is everything based on Lucene, or is there something else underneath? It's all Lucene.
Okay.
There's nothing else underneath. So there's some good things about that, there's some drawbacks about it. Okay. So for example, Lucene does not handle binary data really well. So if you want a document store to do binary data, this isn't going to help you.
Does it use like a character encoding by default, or does it support UTF-8?
UTF-8 by default, but the Lucene core and by extension Elasticsearch and Solar support a wide variety of languages and language types and all the standard Lucene analyzers, filters, all of that stuff that you can apply. You can set it up in the mappings to do all that kind of stuff. Okay. So that's, this is a little bit of the structure of the document, how this is put together. And the nice thing is you can do this in any language, even though it's size specific. So a little bit about some of the search query. So in the top, we're looking, it's basically the field is user and the query is kimchi in this case. The second one is, it's the same query